Let's discuss our fifth chapter, limits, continuity and its differentiability. Limits, its continuity and differentiability. You already learned about the limit in class 11, and in class 12 you have to learn about the continuity and differentiability only. But before that we have to revise some formula of limits. That will be very important in this chapter. So how can we evaluate a limit? We have some formula for that, right? We learned in the class 11, this is limit x tends to a x to the power n minus a to the power n by x minus a is equal to n a to the power n minus 1. Second, this formula is very important for every algebraic function that is based in this form. And we have three more formulas for trigonometric function, that are limit x tends to 0, sin x by x equal to 1. This is in the 0 by 0 form, that is indeterminate form. Third, limit x tends to 0, cos x is equal to 1, because cos 0 is equal to 1. Fourth, limit x tends to 0, tan x by x equal to 1. You can revise some more formula of exponential function and logarithmic function also. We already discussed in the class 11th. Right? So these are some very important formula for to evaluate the limit. If we have a limit in a rational function, then you can evaluate by either direct substitution method, but if those are in the form of 0 by 0, then you need to factorize and then simplify that function. And if you have a square root function, then you need to rationalize that function and then find the limit. Then these are the concept of the limit that you have already know. Now, in 12th class, we have to know about the continuity and differentiability only. So first of all, we have to discuss about the continuity. What do we mean by continuity? Continuity means continuous. The very simple concept of continuity is, if graph of a function is continuous, then function is continuous at all real numbers, at every point, at all real numbers. But if graph of a function breaks at a point, then that is the point of discontinuity. That function is not continuous everywhere. You know about the graph, you learned in the function, the graph of the function. But generally in signum function, we have to check the continuity and differentiability. Otherwise, if you have a polynomial function, the graph is always continuous. As you know that. If you have to draw the graph of a quadratic function, quadratic algebraic function, quadratic polynomial function, the graph is what? Parabolic. Parabolic graph also. The graph is always continuous. If you draw the graph for cubic polynomial, the graph is always continuous. So the graph of polynomial function is always continuous. So we can say that the polynomial function is continuous everywhere. Now you know the graph of sin x, trigonometric function. The graph of sin x is continuous again. Continuous. You know the graph of sin x. If we draw the graph of sin x, this is the continuous, this is the periodic function and continuous graph. Yes, this is the graph of sin x. And negative side also. This is continuous function. So we can say that sin x is continuous everywhere. And you know the graph of cos x is also continuous. By the same way, we can start with here. That is the graph of cos x. That is also continuous. And the graph of tan x is not continuous everywhere. It breaks at a point. Where the graph breaks, that is the point of continuity in that case. So, if you draw the graph of tan x, if you draw the graph of tan x, you know what type of graph is there? Yeah, this is the graph. You know this point is pi by 2. Yeah. You know this point is minus pi by 2. Now 3 pi by 2. Again, this point is pi. This point is 3 pi by 2. So, we observe that the graph of tan x breaks at a point pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2, minus 3 pi by 2 and so on. So graph breaks as a point odd number multiplied pi by 2. So that are the point of discontinuity in this case. If we have a function tan x, y equal to tan x, yeah, fx equal to tan x. This is not a continuous function. But sin x and cos x are continuous functions. So some functions are continuous always that are very important. First one, polynomial function. Polynomial function are continuous everywhere. Everywhere is all real number. Second, sin x, cos x are also continuous everywhere. This is also continuous everywhere, all real number. Because graph not breaks. Now this is the simple method to find a continuity, that is the graphical method. You can draw the graph of every function, you can find the point of discontinuity or the function is continuous everywhere. But in the case of signum function, it is little bit difficult to draw the graph for that. If you have some signum function, in some difficult function, in some lengthy function, it's very difficult to draw the graph. In that case, we need to derive a formula to check the function is continuous or not at a particular point. So let us discuss, let us derive a formula for the continuity. Most of the question is in the form of signum function in this chapter. So let us see if we have a graph of a function y equal to fx and the function is this. This is the graph. Let us see. And the function is y equal to fx. At particular point, this one, we have to check. Suppose this point is a0. So at this point, we have to check this function is continuous or not. So how can we check this? We have to find its continuity at 2 points. Just before that point and just after that point. Now this is very little change in this, very little change. That change is nearly equal to 0. So we have to find the value in this and this. If both values of the limits are equal, then we can say that the function is continuous. So in this point can be written as a plus h comma 0, where h is what? Where h tends to 0, h is nearly equal to 0, and this point is called a minus h comma 0. What is h? H is negligible. This is very little change. So if we find the limit, you can say that if limit x tends to a minus is what? A minus is what? A minus h. H is very little. H is negligible. Fx is equal to limit x tends to a plus fx is equal to fa. Fa is what? This point. If the value of these 3 points are equal, then we can say that the function is continuous. If LHL is not equal to RHL, then the graph is not continuous. Graph breaks at this point. So we can check the continuity of a function at a particular point. We consider the point A in this. So now this A minus is called left hand limit. This is called the left hand limit, and this is called the right hand limit. Little bit we discussed in class 11 also. We did 4 and 5 questions from NCERT in class 11 like this, LHL and RHL. And this is a very important concept to find the continuity without drawing the graph. If you draw the graph, you can write the answer directly by observing the graph. Function, the graph breaks or not. But if you don't draw the graph, you can find by this formula. You can find left hand limit, right hand limit, and then fa. If all three are equal, then only we can say that the function is continuous at point A. In signum function, generally the point of discontinuity may be the point of signum, may be the signum point, right? So in the case of signum function, observe the signum point and check the continuity at that point only. That may be the point of continuity or the point of discontinuity, right? So this is a very important formula. You can write this formula, note down this. And let us see with an example how to find continuity or discontinuity at particular points. Let us observe this. We have a question, find all the point of discontinuity if a function is x plus 1 where x is greater than or equal to 0 and x square plus 1 when x is less than 0. Find all the point of discontinuity in this. So you know, if x is greater than or equal to 0, the function is a y equal to x plus 1, that is a straight line, linear function, two variables. And when x is less than 0, for negative value, y equal to x square plus 1 is the parabolic function. These both are continuous. So, need not to check less than 0 or greater than 0. We have to check at the point 0 only. We have to check that this signal point maybe graph breaks or not. No need to check at point 1, 2, 3, minus 1, minus 2, minus 3. Always continuous at that point, at these points. So this function may be discontinuous at point 0 only. So we have to find the left hand limit and right hand limit and fa at this point 0 only. at point 0. So first of all, left hand limit. This is limit x tends to 0 minus. 0 minus means 0 minus h. H is negligible. And if you consider 0 minus, means 0 minus means for 0 से छोटी value, just less than the 0. 0 minus h. The function for that is x square plus 1. You must observe the function. What you take in this point. 0 minus means less than 0. We have to consider this function left hand limit. So now we can simplify by substituting this value, because this value is nothing but the 0. 0 minus h but 0. So we can put in this 0 square plus 1 is what? 1. This is left hand limit. Now we have to find the right hand limit. The right hand limit is limit x tends to 0 plus. 0 plus means 0 plus negligible quantity 0.001, 0.0001, that is called 0 plus. Means for x equal to 0, the function is x plus 1 only. The function is x plus 1. Now we can put this value 0 plus 1, it becomes 1. Left hand limit is equal to right hand limit. And we have to find fa also. Fa means f0. For 0 equal to 0, the function is x plus 1. We can write it as 0 plus 1, that is 1. Here LHL is equal to RHL is equal to FA. Here LHL is equal to RHL is equal to F0. Therefore, Fx is continuous everywhere. So there is no point of discontinuity. The question is find all the points of discontinuity. We can say that there is no point of discontinuity in this. No point of discontinuity because the function is continuous everywhere. For according to this signum function, the function is continuous at all positive value and the function is continuous at all negative value. We have to check at 0. And according to this solution, we can say that the function is continuous at all real numbers. There is no point of discontinuity. So this is a concept to find, to check the function is continuous or not. But in generally question, it is given that the function is continuous at some point and find some unknown variable in the given function. That will be very important question for that. For example, the question is, the very important question, if fx equal to root over 1 plus kx minus root over 1 minus kx divided by x and 2x plus 1 by 2x minus 1, right? If minus 1 is less than equal to x is less than 0 and 0 is less than equal to x is less than 1, is continuous at x equal to 0. Is continuous at x equal to 0. Then find the value of k. Find the value of k. It is already given that this function is continuous at all real numbers at x equal to 0. Because 0 is signum point here. For less than 0, function is this. For greater than 0, function is this. There are different functions for less than 0 and greater than 0. So 0 is the signum point. So we have to check the continuity at signum point, but in this question it is given that this function is continuous at x equal to 0. So we can say that LHL is equal to RHL is equal to F0. By that equation, we can find the value of k. So let us see how can we find the value of k. Let us see. First, we have to find left hand limit. You know, left hand limit is limit x tends to 0 minus, because we have to check at the point 0. For 0 minus, we have to write the function where x is less than 0. That function is this one. We have to consider the function root over 1 plus kx minus root over 1 minus kx divided by x. This is left solution. We have to find this value. Now this is 0 by 0 form. Why? If you put x equal to 0 in this, you will get root 1, that is 1, minus root 1, that is 1. 1 minus 1, 0 by 0. This is the form 0 by 0. We need to solve this limit. Now in class 11 we discussed about this type of limit. If you have a square root function, then you need to rationalize that and then simplify. Eliminate that 0 by 0. So we have to solve this limit. It will limit x tend to 0 minus and rationalize this function 1 plus kx minus 1 minus kx by x, multiply with root over 1 plus kx plus root over 1 minus kx by root over 1 plus kx and plus root over 1 minus kx. Just rationalize this, we will get the left hand limit. Limit x tend to 0 minus, it can be written as 1 plus kx minus 1 minus kx by the formula a plus b into a minus b, and x multiply denominator root over 1 plus kx plus root over 1 minus kx. Now it can be written as limit x tend to 0 minus, now 1 plus kx minus 1 plus kx, it can be written as 2kx divided by x, root over 1 plus kx plus root over 1 minus kx. Add x, cancel x, 0 upon 0 eliminated. Now we can put the limit 0 in the place of x. We can write it as 2k by. We can put 0 in terms of, in the place of x. Root over 1 plus 0 is 1 plus 1. That is 2. It can be written as k1. This is left hand limit, k. We find left hand limit. Now we have to find the right hand limit, because you know this function is continuous. LHL must be equal to RHL. Now let us see how can we find RHL. So RHL can be written as limit x tend to 0 plus. Now 0 plus, we have 0 plus. We need to write a function where the function x is greater than 0. For x is greater than 0, we have this function 2x plus 1 by 2x minus 1. We need to write this function here, 2x plus 1 by 2x minus 1. Now we can put the limit direct. The limit is what? 0 plus. We can put 0 here. We will get 0 plus 1 by 0 minus 1. This is not 0 by 0. So we can direct put the limit and write the answer by direct substitution method. It becomes minus 1 only. Now we can find the value of f0 also, but no need to find f0, because you observe that since this function is continuous, so LHL must be equal to RHL. By that we will get k equal to minus 1. Since fx is continuous at x equal to 0, so therefore LHL is equal to RHL. And if LHL is equal to RHL, means we can say that k is equal to minus 1. This is the answer. K is equal to minus 1. This is the answer. We can say that k is equal to minus 1. By this way we can find each and every question related to unknown variable. We can find two variables also. In this question we have only one variable, that is k. But we can also find a question related to two unknown variables, a and b, p and q. Because we have three equations in this, two equations in this. LHL is equal to RHL is one of the equation, and RHL is equal to FA, that is another equation. LHL is equal to FA, that is another equation. We have two or three equations are there. So we can find two or more value in this. In this we have only one variable, that is k, so no need to find FA in this. By finding LHL and RHL, we will get this value, k equal to minus 1. Let us see how to solve the question related to two unknown terms. Two unknown terms. The question is a very important question. If the function fx is equal to a signum function 3ax plus b where x is greater than 1, 11 where x is equal to 1 and 5ax minus 2b where x is less than 1 is continuous at x equal to 1. Then find the values of a and b. Right? We have to find the values of a and b where this function is already continuous at x equal to 1. It is given that this function is continuous at x equal to 1. Means we can say that LHL is equal to RHL is equal to F1 in this. What is the point of signum? The signum point is 1. And it is given that this function is continuous at x equal to 1. So we can find LHL, left hand limit, that is limit x tends to 1 minus. What is the function for 1 minus? Less than 1. The function is 5ax minus 2b. 5ax minus 2b. Now, we can put this value, this x tends to 1 minus means nearly equal to 1. We can put 1 in the place of x. It can be written as 5a minus 2b. This is left hand limit. Now we have to find the right hand limit. The right hand limit is equal to limit x tends to 1 plus 1 plus is greater than 1. For greater than 1, we have this function, that is 3ax plus b. Now, we can put 1 here, we get 3a plus b. There is no 0 by 0 form, we can directly put this. Now we have to find fa, that is f1. For x equal to 1, the value is 11 only. Yes, we can write it at 11. Now this function, we have to find a and b. Very simple. We have to find a and b. This is LHL, this is RHL, this is F1. Since fx is continuous at x equal to 1, we can say that LHL is equal to RHL is equal to F1. So therefore, 5a minus 2b is equal to 3a plus b is equal to 11. Now we have two equations. 5a minus 2b equal to 11 as well as 3a plus b equal to 11. We can solve these two equations to find the value of a and b. We can solve these two equations to find the value of a and b. We can find these values by solving these two linear equations. Right? So by this we can solve the question related to two unknown terms. So these are very simple questions on continuity. You may face some problem to solve the question related to lengthy limits, lengthy function. Like if we have a function, if fx is equal to 1 minus sine qx divided by 3 cos square x if x is less than pi by 2 and a if x is equal to pi by 2 and b multiplied 1 minus sine x by pi minus qx to the square where x is greater than pi by 2. The question is, if fx is continuous at x equal to pi by 2, then find a and b is continuous at x equal to pi by 2. Then find the value of a and b. Same question here. These questions are same. But there is some difficulty to solve this limit LHL as well as RHL. That is very important. You can refer class 11. We already discussed in the class 11. If we have to find LHL and we know that the function is continuous at x equal to pi 2, so the signum point is pi 2 only, we can write that left hand limit as pi 2 minus, and the function is pi 2 minus less than pi 2, the function is 1 minus sine qx divided by 3 cos square x. If you put pi by 2 in numerator and denominator, you will get 1 minus 1, that is 0, and 3 cos pi 2 0. 0. The 0 upon 0 form. We need to solve this function to simplify this, because this is in the 0 by 0 form. So how can we solve this? You know that if limit x tends to pi by 2 minus means what? Pi by 2 minus a negligible quantity, that is h. Pi by 2 minus h. So we can say that h tends to 0. We can convert it in h tends to 0. Why? Because you know the formula for sin x by x equal to 1, where x tends to 0. So we need to convert it as h tends to 0. When h tends to 0, when x equal to pi 2 minus h, so we can write it as 1 minus sine q pi 2 minus h by 3 cos square pi 2 minus h. Now we converted it tends to 0. Now limit h tends to 0, it can be written as 1 minus, you know, sin pi 2 minus theta is cos theta, so 1 minus cos qh by 3 sin square h. Right? Need to simplify with by trigonometry. If now again if you put h equal to 0, this is 0 upon 0 form. Right? Because you know cos 0 equal to 1. So now we have to simplify limit h tends to 0. How to simplify this? Very difficult to understand. Let us see 1 minus cos qh. We can apply aq minus dq this because we don't have any formula in trigonometry to simplify this. So 1 minus cos qh, we can apply aq minus dq. This is 1 minus cos h multiply 1 plus cos h plus cos square h divided by 3 sin square h. 3 sin square h. Yes. We have to simplify this left hand limit. So now this can also be written as limit h tends to 0. 1 minus cos h can be written as 2 sin square h by 2 and divided by 3 sin square h and multiply with 1 plus cos h plus cos square h. Yes. If you divide numerator and denominator by h square, we can simplify this function. 2 by 3 is constant. We can take outside limit h tends to 0. If we take sin h by 2 multiply sin h by 2 by h divided by sin h by h multiply sin h by h. We can solve this. Divided numerator and denominator by h square and separate sin square h by 2 as sin h by 2 into sin h by 2 and multiply again limit h tends to 0 and 1 plus cos h plus cos square h. Now you know the formula limit x tends to 0 sin x by x equal to what? 1. The function of sin and denominator will be same. So here h by 2, if we divide it with 2, it becomes sin h by 2 by h by 2. That becomes 1. If you divide by 2, you must multiply by 2. So 2 by 3 multiply 1 by 2 multiply 1 by 2. And sin h by h is 1, sin h by h is 1. Multiply. If you put x is equal to 0 here, cos 0 is what? Cos 0 is 1. Cos square 0 is 1. It can be written as 1 plus 1 plus 1. Right? Simplify this. 2 is cancelled 2, 3 is cancelled 3, you get 1 by 2. This is the left hand side, 1 by 2. Now we have to find the right hand limit, that is limit x take to pi by 2 plus. For pi by 2 plus, the function is this one, b multiplied 1 minus sin x divided by pi minus 2x whole square. Now again we have to convert it in terms of 0. It tends to 0. Pi by 2 plus h, when h is tends to 0, we can write it as pi by 2 plus h in the place of x. Pi by 2 plus h divided by pi minus 2 multiplied pi by 2 plus h whole square. You can simplify this. Limit h tends to 0. b multiplied 1 minus, sin pi 2 plus theta is what? Cos theta. Yes, it can be written as cos h divided by pi minus pi and minus 2h. So finally this is pi minus pi cancel and minus 2h whole square, that is 4h square. Right? We can simplify this, very simple. We can write it as limit h tends to 0, b multiplied 1 minus cos h 2 sin square h by 2 divided by 4h square. Now this is cancelled and b by 2 is constant. Limit h tends to 0. We can write it as sin h by 2 by h multiplied sin h by 2 by h. H square can be written h into h. Now sin h by 2 by h is what? 1 by 2. Again we can divide and multiply 2. We can apply this formula to find. So b by 2 multiply 1 by 2 multiply 1 by 2. It becomes b by 8. Right? b by 2 multiply 1 by 2 multiply 1 by 2. It can be written as b by 8. Now this is the left hand limit. Here left hand limit 1 by 2. Right hand limit b by 8 and f pi by 2. F pi by 2 is already given, that in A. Now since LHL is equal to RHL is equal to f pi by 2. Why? Because this function is continuous. So LHL can be written as 1 by 2 is equal to b by A is equal to A. Yeah, we'll get the value of A and B. This way we need to find that. Now we can say that A is equal to 1 by 2 exactly and B is equal to 4. Right. So these are the values of A and B. You may face some difficulty in this type of question that you learned in class 11. If you know the formula for trigonometry, that will be very simple, no problem. So these are the concept of continuity. You can solve each and every question related to continuity. You must know the concept of continuity to find, to find the LHL and RHL only, left hand limit and right hand limit. Then you can solve each and every question. One very simple topic, that is differentiability. Differentiability. You know about differentiability? If a function is differentiable, means we can differentiate that function. We can find the differentiation of that function. So how to find differentiability of a function? Let us see. Continuity is over. You have to solve the question related to continuity. Now we have to discuss a very small topic, that is differentiability. Differentiability. A function is differentiable, then only we can differentiate that function. So how can we say that a function is differentiable? For that we have to find LHD and RHD. According to graph, if we understand the point by graph, Let us see what would be my derivative. This is the change in one variable with respect to another variable. If you have a graph like this, y equal to fx, let us see, this is the point A. This is the point A. This is the point A. And this is the point of point. This point can be written A multiply fa. This point is called A comma fa. You know, function y equal to fx. So, what do you mean by slope of this? Slope is called change. We have to find the function in this function y equal to fx is differentiable or not. Yeah, this function is differentiable when it is continuous at that point first, and we have to find the slope at this point as well as this point. What are these points? These points are just, this point can be written as a minus h, and this point can be written as a plus h. We have to find the value at this point, means we have to find a minus h comma f a minus h, a plus h comma f a plus h. So, LSD, that is left hand differentiability, that is very little change in A. We can say that f A minus h minus f a divided by minus h, that is A minus h minus a. Change in fx with respect to change in x, that is called derivative. Change in fx with respect to change in x, where a minus h tends to a, means h tends to 0. And what do we mean by RHD? Same thing. Limit h tends to 0, f a plus h minus f a divided by h. Change in this one. Change in y-axis with respect to change in x-axis. Change in y with respect to change in x. This is called LSD and RSD. So we have to find the LSD at this point and RSD at this point. We'll get that value. You can write this is a minus h and this is a plus h. Right? So these are LSD, and you can find LSD as well as RSD in these points. If both are equal, then we can say that the function is differentiable. And the basic formula for this is f x minus f a divided by x minus a, where limit x tends to a. This is a very important formula that shows the change in fx with respect to change in x. Now we can say that if LSD is equal to RSD, then function is differentiable at that point. At this point where we found the LSD and RSD. If LSD is equal to RSD, then function is differentiable. So let us see from an example, we will better understand with an example. The question is fx is equal to 1 minus x, where x is less than 1. 1 minus x, 2 minus x, when 1 is less than equal to, x is less than equal to 2, and 3 minus x, x is greater than 2. Very important. The question is, discuss the continuity and differentiability. Discuss the continuity as well as differentiability. The very important concept, if a function is differentiable, it must be continuous. Why? If a function is differentiable, means we can differentiate that function, that must be continuous. Because we cannot differentiate the discontinuous function. If a function is continuous, it may be differentiable or not. But if a function is differentiable, it must be continuous. So if we have to check continuity and differentiability, when you check about the differentiability, you can say that since the function is differentiable, it must be continuous. No need to check the continuity in that. In this question, the question is discuss the continuity and differentiability. So we have to check differentiability at 2 points because there are 2 signal points. First of one and second 2. There are 2 signal points. X equal to 1. This is first case. So we need to check the differentiability at x equal to 1. So first we have to find LHD, that is limit x tends to 1 minus, and the function is f1 minus, the function is fx minus f1 divided by x minus 1. Now in the place of x we can write 1 minus h. If we write limit h tends to 0, it can be written f1 minus h minus f1 by 1 minus h minus 1, that is minus h. We need to simplify this, we will get LHD. How can we simplify? Here function fx for less than 1 is what? 1 minus x. So if 1 minus h, we can put 1 minus x. We can put limit h tends to 0 and 1 minus, in the place of h we can write 1 minus h. This is the function, right? Minus f1 for x equal to 1 function is this. So it can be written as 1 minus 1, that is 0. And divided by minus h. You can simplify this, limit h tends to 0, 1 minus 1, 0 plus h. It can be written h by minus h, that is minus 1. This is left hand differentiability, minus 1. Now we have to find RHD at x equal to 1. It can be written as limit x tends to 1 plus, and the function is fx minus f1 by x minus 1. The function is always same. Change in fx with respect to change in x. It can be written as limit h tends to 0, f1 plus h minus f1 and 1 plus h minus 1, that is h. Now we have to simplify this one. We have to simplify this. It can be, RHD can also be written as limit h tends to 0. Now see the function for 1 plus h means greater than 1. The function is 1 minus x, 2 minus x. So we can write it as 1 minus 1 plus h and 2 minus 1 plus h minus f1. What do you mean by f1? 1 minus 1, 0. Multiply anything 0. Divided by h. Now we have to simplify this, limit h tends to 0. 1 minus 1, 0 and minus h. And multiply 2 minus 1, that is 1 minus h divided by h. It can be written as limit h tends to 0. We can cancel this h with h. We will get minus of 1 plus of h. You can put h equal to 0, it becomes minus 1. Now LHD minus 1 and RHD is also minus 1. So since LHD is equal to RHD, so therefore fx is differentiable. Fx is differentiable at x equal to 1. Fx is differentiable at x equal to 1. This is one of the signum point. Another signum point is x equal to By same way, we have to prove in the second case, we have to find at x equal to 2. We have to find LHD as well as RHD for x equal to 2 as x equal to 1. Then we can also say that fx is differentiable at x equal to 2 or not. So this is very important concept to find LHD and RHD to check the differentiability. So we can say that this function is differentiable at x equal to 1. And what is f dash 1? What is f dash 1? So therefore f dash 1 can be written as, and therefore f dash 1 can be written as minus 1. That is LHD and RHD. So if a function is differentiable, that means we can differentiate that function and we can find the differentiation at that point. We have to find the differentiation at point 1. So f dash 1 can be written as minus 1. If you differentiate that function and put x as 1, we will get minus 1. By that way, we can find the differentiability at x equal to 2. And if a function is differentiable at x equal to 1 as in x equal to 2, it must be continuous at x equal to 1 and x equal to 2. Right? So these are all about the continuity and differentiability. One very important theorem that's very simple that we need to discuss in continuity, that is, if two functions f and g are continuous, then f plus g, f minus g, f multiply g, f by g, f o g and g o f are also continuous. This is a very important point. Means if sin x and cos x are continuous, so we can say that sin x plus cos x is also continuous. The graph is continuous. There is no break. Sin x minus cos x also continuous. Sin x multiply cos x also continuous. Sin x by cos x also continuous. Where g is not equal to 0. There is some restriction in this point because g is denominator. Because you know tan x is not continuous everywhere. If we have a function x square and another one is sin x, let us see fx is a function that is sin x and gx is another function that is x square. So means we can say that x square plus sin x is continuous, x square minus sin x is also continuous, x square multiply sin x is also continuous. You can draw the graph for that. You can draw the graph and check that continuity. Very simple. So this is very important theorem to solve the question. For example, if we have a question, prove that mod sin x is continuous. How can you say that mod sin x is continuous? We need to consider two functions here. First one fx sin x. Second one gx mod x. So what do we mean by g of f? That is g of fx. This is mod sin x. Yes. If we have to prove mod sin x is continuous, we have to check the continuity of mod sin x. We can consider two functions, sin x and mod x. If we find GOF for that, the GOF can be written mod sin x. Since fx and gx are continuous, because you know that the graph of mod x is always continuous. Since sin x and mod x are continuous, so GOF, that is mod sin x, is also continuous. We can apply this theorem. FOG and GOF both are continuous in this case. So sin mod x is also continuous. This is a very important question from NCERT. You can also say that mod sin x plus mod cos x, that is also continuous, right? So these are all about the continuity and differentiability. The rest thing we'll discuss in the next class. Okay.